Welcome to Kubernetes deployment methods. We're going to cover 3 deployment methods, and although there are more, these 3 build upon each other, and they are an excellent foundation for anyone getting up to speed on Kubernetes. First, we're covering kubectl. The default way of interacting with Kubernetes is through the command line interface using kubectl, also known as kubectl. And before we get into that too much, I wanted to mention that although we think of Kubernetes as container management, you can also think of it as a controller manager. And by controller manager, I mean a controller processing engine. So if you take a look at the 2 images below, in the second line, we have a kind deployment and we have a kind service. So there's a controller that knows how to process a deployment, and there's a controller that knows how to process a service. So by default, Kubernetes provides controllers that interact with and work with containers. But you can actually create controllers for anything to process a game like tic-tac-toe or whatnot. It's just by default, you get the controllers specific to containers. And that's what most people think about, but it's something that you can extend. And we can talk more about that later, things that extend what Kubernetes is capable of. So in this demo, we are going to create a deployment. We are going to expose that deployment, and then we will expose it again at another level using an ingress so that we can access the deployment using a URL. So let's go ahead and get started. So here we are, secure shelled into a system configured with Kubernetes, which we can check by looking at the nodes available. And there we are connected. I've created an alias for kubectl as K just to make things easier. So initially we'll just create a namespace to put everything into. And we'll call that test. We'll change into test. And we'll look what's in there. There's nothing, of course, because we just got started. So in a Tanzu environment and with a Kubernetes cluster by default, you cannot create pods without first creating a pod security policy. So without going into that too much, we'll go ahead and apply one here. And now we can create pods. So let's go ahead and create our deployment. We're going to deploy WordPress. We'll call the deployment test. And we could just say WordPress as our image and it would pull from Docker.io. But there is a rate limit at Docker.io. So what we do is we use an on-site container repo, Harbor, and we've configured it with a proxy for Docker.io. So it does just what you would think. If there's a new version of WordPress, it'll pull that down. Otherwise, it will pull the locally cached version. So I'll go ahead and deploy that. I'll use watch so we can see what's going on. And it was really fast, but it must already be cached there. What I was hoping you would see is that before you would have this status running, it would show that it's creating the pod. But it already pulled the image and it created it that quickly, so we are good to go. So now we have a pod running, but we can't access it directly. So within Kubernetes, you have like say 3 worker nodes and there's a subnet between the 3. And whenever you deploy thing on any of the worker nodes, they can see each other because they're all on the same subnet. And right now it's in there, it's using that cluster IP. I'd like to show you that it's running though. So I'll go ahead and start up Chromium. And what we can do is we can run a proxy command and we can proxy test or port forward the test pod. We're going to use localhost. We're going to open up a port 8080 on the localhost machine, and we're going to redirect that to port 80 inside this pod. So now we can go over to Chromium and look at localhost 8080. And there we go. What do you know? It's working. All right, so I'll stop this port forward. And now we need to expose it so that we can actually access it from the outside world. So we're going to expose the deployment test. We're going to give this exposed deployment a name. We're going to call it test. when you expose it, it calls it a service. You'll see that in a second, but we'll name the service test. And the port we're going to listen to from the external world is 80. And the target port inside the pod is going to be 80. So now we have a service there, this line here named test, and it's still using a cluster IP. So I'm going to edit that service just so that we can see that it's working to expose it to the world. And I'm going to change the type. So by default, we're using a cluster IP. You can also use a node IP. That's the IP of the worker node that the pod is running on. But we're going to use the load balancer IP. So make that change. Watch get all and see if it's fast enough. So see, it's pending here under the external IP, and now we have an IP. So it pulls that IP from the available range of IPs, and now from the outside of the cluster, we should be able to access the WordPress site. So by that IP. And there we go. So it's not secure because we're using port 80, but it can receive on port 80 at that IP and then redirect into the pod. But there was no TLS, right? Not secure. We want to make it secure and generate our certificates. So I'm going to go ahead and edit that service again real quick. Change that load balancer back to just a cluster IP because we don't need a load balancer IP anymore. We can see that it's gone now, back to none. And now we're going to use an ingress instead. So an ingress is like an external thing. It doesn't come native with Kubernetes, so I can't create it using the kubectl command, but I can create it using this YAML file. So let's go ahead and take a look at that. And I've just named it test for the ingress. I can show you these 3 lines are specifically to generate the cluster. So they use another program, Cert Manager, and this is communicating to Cert Manager that, hey, we'd like some certificates. And then just looking a little more, initially an ingress can just be used for port 80 without the certificates, and for that area under rules here, we've got the FQDN that we're going to use. And here's the service that we're targeting. We name that service test, and the port from the external world, the ingress port, is 80. And here's the TLS section. So this is for the certificate specifically. We have to specify the FQDN again. And here's a secret that's going to be created that contains our certificates. So if I just go ahead and apply the ingress, I can look at it. And there it is. So it doesn't have an address yet. That can take a few seconds. So let's go ahead and watch that. Oh, okay, we're already good to go. So now we should be able to access it using this FQDN. And before I do that real quick, I'll just go ahead and show you that we also have secrets here now. And there's the secrets, the TLS certificates that we created. All right, so now I'm going to use a different web browser. I'm going to use Chrome because it works a little bit better. And let's go ahead and try out that URL. And there we go. So now we have our certificates. This connection is secure, and let's make sure, yeah, certificate is valid. All right, so now we have a site that we can access that we have stood up with certificates. The DNS has been registered in Infoblocks in this case, and we are good to go to start using this website. So on to our next deployment strategy. And to review, here are the 3 deployment methods that we are covering in this video. We just covered kubectl, which requires us to manually create our deployments, the service, and the ingress. And next we will move on to Helm, which uses templating. So when it comes to Helm, you have something called a Helm chart. And inside that Helm chart, there are templated values, such as a deployment, a service, an ingress, and whatever other objects are required for the deployment. And since we don't have to deal with creating those ourselves, how do we customize, right? So in the previous deployment, we wanted an ingress with an FQDN. We still have to specify that FQDN somewhere. And with Helm, you do that through a values.yaml. So all we have to do is specify the Helm chart and then a values with our customized values, and then we are good to go. Everything else should just happen after that. So let's go ahead and demo that. Here we are connected to that same Kubernetes cluster, and I will delete the namespace test. just to show that we are starting from scratch. I'm going to create the namespace again. Let's see if anything's in here. Nothing's in here. All right, so we have our values file that we can deploy with Helm chart. But before I do that, I wanted to take a look at where this came from. So if you just do a Google search for GitHub and charts and WordPress, you'll find a few options out there. I like Bitnami. This is something I've looked into before. Bitnami is associated with VMware. And if I click here, you can see there's actually quite a few charts. So if you want to deploy Apache or a cert manager, which we've talked about before, quite a few things here. FluentD for capturing logs from pods. So Grafana for displaying charts and displaying metrics. Prometheus is down here as well, I believe. Well, maybe not. But in any case, I just want to show you there's quite a few here. So the idea of using kubectl to just deploy everything manually, you don't usually have to do that. Generally, there's something out there already and the team's already maintaining it, and you can take advantage of that. So we'll go ahead and jump down here to WordPress, but since that's the one we're going to use. And I talked about this being a templating engine here. So Helm uses these templates in this chart, and we can see that there's more than what we created manually. So we got the deployment here, the service here, the ingress here, and if we click on that, not to overwhelm you, but basically you've got your values from the values YAML, and those get inserted here into the YAML here, creating a customized YAML. Some of this should look familiar. We've got our ingress, and the spec and the rules, and we're going to put our host name next to host, right? We've got our HTTP section, and down below the service name that's going to be included in the port. But not to be overwhelming, we'll just back out of there and show we do have our template files. And then we also got our values here. So usually there's a README like this, and it shows you how to get started. You can just run these 2 lines to deploy things. But then we won't have our certificates and we won't have our FQDN. That's just a very minimal deployment. As README often, as this one does, also has requirements of a minimum Kubernetes version, which we meet. And it starts talking about the values you can set. But if you want a more technical view, you can click on the values.yaml here for all the default values. So if you don't set the value, this is what you got. And you can come in here and really just look at everything that's offered by the Helm chart that you're investigating. So we're going to use this one to set the default password. And there's also the ability, you can see, to set the email. We won't go into all this. I just wanted to show you where it comes from so you can take a look as you start to use Helm charts. So let's go ahead and give it a shot. So here we are, and I've already, well, let's go ahead and look at the Helm chart that I came up, or the values that I've come up with. So basically I'm specifying the local container repo, and there was another opportunity to specify that local repo, so I went ahead and set it just to be sure. And then here's our ingress that we talked about. So TLS, we do want our certificates to be generated and used. Nginx, and here's the FQDN that we're going to use. And our certificates are going to come from Cert Manager using annotations, just like we did before with the manual deployment. This TLS, actually all it does is point to 443 rather than 80, but we have to use that since we are using our certificates. And then here's a default password that we set, otherwise it'll choose a random one for us. And I don't want to go into these too much, but because of the version of Kubernetes we use, we had to make some adjustments because some of the features are only available in the newer version. But in any case, we don't need to talk about that now. Let's go ahead and give it a shot and see what happens. So we're going to call our Helm deployment test, and we're going to specify the WordPress Helm chart and the values file that we just created. And in Helm, you'll often get a summary page like this, which tells you how to get started. So for example, if we had used the randomized password, this is the command we could run to obtain that password. Let's just see what's going on. Oh, I did recreate that namespace. So again, I need to apply that pod security policy we talked about. All right, now let's see what's going on. It'll take a second before it retries deploying those pods. Okay, so it's creating a Maria database and a WordPress pod. They both downloaded the images and have started up. There was also an init pod there running, but it happened so fast it's already done. That init pod was initializing one of the data shares and setting the username and group just to make sure everything could be accessed. But that's not important now, it just happens automatically. So both pods are running, but they're not in a ready state. They're not ready to receive connections yet. So we can look at their log files while they're processing. So the Maria is already done, but we can take a look and yeah, it's ready to go. And then there's also the WordPress site. Take a look in there. And it's working on it. Starting Apache. So we can scroll back up. But things look like they're coming along. Let's just see what's going on again. All right, so everything's running. Let's go ahead and look at the ingress as well. And that looks like it's good to go. So now we should just be able to access the WordPress site at that URL. And there we go. We've already got our certificates. Connection is secure. Certificates are valid. And it's ready to be used. I know from previous usage I can type log in there. We can log in with our user password and start making things happen. All right, so that's it for Helm. Let's go ahead and move on to our next deployment method, which will use Helm, but in a way which incorporates Git. To review once again, we have the 3 deployment methods that we're covering in this video. First, we used kubectl and did everything manually. And then we used Helm to deploy a Helm chart that somebody else created, which made things a little bit more involved. We had it added in a database and some other features. And all we had to do was specify what values we wanted to customize. Now we will move on to argocd, which is going to deploy the Helm chart that we created before using our specified values file. And it's going to do that through the use of Git. So let's go ahead and move on to that. We're not going to go into argocd too much other than to add to a Git repo, which is already configured to work with argocd, and then deploy an application which will reference what we added into Git. And then we'll take a look within the argocd interface and look at everything in a really nice graphical way. Once again, we are on that same Kubernetes cluster. And I am in a folder which I have created for use by argocd. So argocd uses this application set, and here it is at the top level. We don't want to go into it too much other than to say we are targeting a Kubernetes cluster, and we're giving a name to our deployment, and it's specifying which Git repo to look into, as well as a path to the WordPress files. And you can specify items related to values within the application, but we're not doing that. So I've just gone ahead and commented them out. And we are by default going to create a namespace. So again, just to look at what we've got here, we've got this application set, which is used by argocd. And here we have a chart file. Let's go ahead and take a look at that. That's just, we're calling it WordPress, and it's pointing to the Helm chart that we spoke about in the last video. So we've got our Bitnami reference to WordPress, and in this case we had to specify a version. We couldn't just say latest. So I went ahead and looked that up. You can look it up with Helm search repo Bitnami WordPress versions head just to show the last few, and there we go, 15 to 16. So again, to look at our files, We have the chart, which says which Helm chart we're using. And then we need our values file. Let's copy that over real quick. There we go. So there's our values file. And then we also have this templates folder, which contains our pod security policy. So essentially what we have here is we've defined our own chart with just some minimum files, so the familiar files that you saw before when we looked at the Helm. We've got our values file, the chart file, and the templates folder. Even though we don't have much in there, we've only got our pod security policy and our values that are important. And yeah, otherwise it points to the original Helm chart that we used when we were talking about Helm. So let's go ahead and get all this into our repo. I cached my password there. All right, so it's in the Git repo, and in theory, we should just be able to apply this application set. So here is our argocd deployment. I already have a couple things deployed out there. Let's give this a shot and see if we get it first try. Oh, is that the wrong argocd instance? There we go, if I go to the right place. And here we have our WordPress instance. So it's still progressing. We can click here and see things in a nice layout. Items that you would be familiar with. We've got our service here. And it's got a service also for the Maria database. And here is our deployment, which results in a replication set. We've got our secrets that get created. Where's our TLS secrets? Well, in any case, we'll give it a minute here. We can check inside the namespace as well. We got to go over to WordPress. No longer using test. And there we go. We don't have a deployment of. All right, so it took me a second there, but we have to indent the values file now that we have the chart at the upper level. So WordPress there, and then I had to indent a couple spaces. Just make the formatting nice. All right, so we've got our fix in place. It wasn't seeing any of our customizations. All right, so now we just need to wait up to 3 minutes for it to recognize there's a change in the Git repo. Or we should be able to just click refresh also. Let's give that a shot. All right, so out of sync, and now it's synced. Initial commit of WordPress deployment. And then, all right, here's our new update. Corrected formatting needed to indent by 2, and things seem to be better. So now we have our ingress here. There's our URL that we'll be able to click on when it's ready. It's not ready yet, so, oh, maybe it is. Sometimes it just takes a second to update within this tool, but looks like we are good to go. Got here, so yeah, still progressing, and yet looks like we are good to go. Got our certificates. Yes, certificates are valid. And we can log in. Password. And there we go. Third method complete. So the thing about argocd, which is kind of fun, is since it's maintaining a state here, if anybody messes with it, we'll get our ingress, we'll just delete the ingress, and then we'll watch kget ingress. You see it's already back. You saw it disappear visually, and then it recreated it, and now it still has to get the address, I suppose. So we'll just give it a few seconds here. But you can see how you have to make your changes through Git. Even if somebody did actually go into the Kubernetes cluster and make a change, it would be reverted back because there's a tool in there, argocd, that watches Git, and whenever it sees something over there that it's maintaining, it reflects that into the Kubernetes environment, always making sure that whatever's in the Kubernetes environment is what it's finding in Git. So, all right, done demoing Git. All right, so today we gave a high-level overview of 3 different deployment methods, starting with a manual kubectl, implementing a Helm chart, and then moving on to GitOps. So for those interested, here are the commands that we ran using kubectl to do everything manually. And then here are the commands to install a Helm chart. And then here is the folder structure. We created a custom Helm chart that referenced another Helm chart, and we deployed that using an application set. I hope this has been beneficial, and have a great day.